Alrighty, people, this is the question that I posed in class, trying to find the enthalpy for an ethanol alcohol lamp burning and heating up a cup of water, 8.2 degrees Celsius or Kelvin, same thing, and you have to find the enthalpy. Okay, and that is the balanced chemical, or sorry, that's the chemical equation rather, not balanced yet. Uh, we have excess oxygen, so we don't really need to balance it, but just in case. There we go, there, balanced. And we're going to put in our information that we know now. The mass of ethanol, it all gets used up, so I can figure out how many moles I have. But before I do that, I have to figure out how much heat has been transferred to my cup of water. And I do that using Q equals mc delta T. The mass of water is 250 grams because it's the water that's being heated up. I'm trying to figure out how much heat has been absorbed by the water. Where'd that heat come from? It came from the ethanol burning, combusting, releasing all that energy. But it went to the water. So that's why I'm only concerned about the mass of the water, not the ethanol. C is 4.18 for water, so that's really easy. And then just going to write in my 8.2 temperature change, and that gives me what Q is in joules. Q is 8,569 joules. If you want to do 2 sig figs and use it in kilojoules, we're talking about 8.6 kilojoules. And so I just need to go delta H is Q over N. So it's 8.6 kilojoules divided by whatever N is, which we haven't figured out yet, but here we go, just figuring out the moles of pure ethanol there. And it is 1.41 moles if you divide by the molecular mass. And so we just have to divide those two numbers in, 8.6 divided by 1.41. And if you got 6.1 kilojoules per mole, you are wrong. It would be negative 6.1 kilojoules per mole because this is obviously an exothermic reaction. It's a combustion reaction, and all combustion reactions are exothermic. And there is how you do an enthalpy question. I will see you all in class tomorrow, provided that I don't forget about you.